This question I didn't understand either. Is there some baseline level of partial observability that can guarantee completeness of a search algorithm? I don't know, maybe this is left over from earlier in the class and I just didn't notice it, but I think I emptied the box. Completeness of a search algorithm, so that's, I assume by search that means like heuristic search, so a heuristic search algorithm is complete if it finds a solution when one exists. So like it'll find the answer if there's an answer. Now, partial observability, we haven't really dealt with that at all, really, in the algorithms we've dealt with. I hand-waved about conformant planning for a few minutes because some folks were interested in it. Now, if you're doing search as part of a planner for a partially observable domain, you could still have completeness. The partial observability of the problem domain would be captured somehow in this representation of a state, what it means to be in a particular state. But as far as the search algorithm is concerned, if there exists a plan through this, perhaps you're searching belief space, for example, if there exists a plan, then you want to be able to find it. So they're completely independent considerations. Completeness is at the level of the search algorithm. Partial observability is part of the planning domain that you probably want to be designing your search space to handle. Why is first-order logic considered inefficient? We will talk about that today. What is faster and accurate? So it depends what you mean by accurate. If you mean expressive, like, oh, God, you can't. The next step down from first-order logic, in my view, is well, there are description logics, which we'll talk about on Wednesday briefly, where you can't say very much. But it looks a lot like first-order logic. The next step below description logics are like propositional logic, and propositional logic is just pathetic. Like you can't even say Mary likes the color of one of John's ties in propositional logic. Like you can't say that. So, not that we all need to say exactly that, but being able to express indefinite information or make assertions in conditions of incomplete information, like I don't know exactly which tie it is, but I know there exists a tie that she doesn't like the color of. That's a very useful thing to do. Now, accuracy, so expressivity, we want a logic with sound inference rules, probably, if you want to have your inferences be valid. But there are sound inference rules for propositional logic, so we're good there. But it's just not very expressive, so it's terrible. But propositional inference is only NP hard, so it's a lot better than first-order logic, which is semi-decidable. And we'll talk today about what semi-decidable means.